Welcome to Module 13, Hazard Ratios. This is the measure you'll encounter most often in survival analysis and time to event studies. It's related to the risk ratio, but it's more sophisticated because it accounts for the timing of events over the entire follow-up period. Let's break it down. Ratio compares the instantaneous rate of an event between two groups at any point during the follow-up period. Think of the hazard as the risk per unit time at any given moment. It can change over time, but the Cox proportional hazards model assumes the ratio between the two groups remains constant throughout the study. This is called the proportional hazards assumption, and it's important to verify in any survival analysis. The hazard ratio is particularly valuable because it handles censoring, animals that leave the study before experiencing the event, which is a reality in almost every veterinary longitudinal study. The key distinction between a risk ratio and a hazard ratio. The risk ratio is a snapshot. It compares cumulative risk at one fixed point in time. The hazard ratio is a movie. It compares event rates across the entire follow-up period and accounts for when events happen, not just whether they happen. If you have a study where animals are followed for different lengths of time, or where some animals are lost to follow-up, the hazard ratio is the appropriate measure. Kaplan-Meier curves are the visual companion to hazard ratios. Each step down in the curve represents one or more events occurring. The tick marks along the curve represent censored animals, those that left the study without experiencing the event. When you're reading a paper with a hazard ratio, always look at the Kaplan-Meier curves alongside it. If the curves cross each other, that's a red flag. It suggests the proportional hazards assumption may be violated, which means the HR may not be a valid summary of the relationship between the groups. Ratios are everywhere in veterinary clinical research. In oncology, they're used to compare survival times between treatment protocols. In dairy medicine, they're used to compare time to conception or time to lameness resolution. In equine reproduction, they describe time to first ovulation. When you see a hazard ratio in a paper, interpret it as the relative rate of the event at any given moment. An HR of 0.55 means the treated group had a 45% lower rate of the event, death, disease, or whatever the outcome is, at any point during the study. That's a clinically meaningful reduction. Is interpretation focused rather than calculation focused, because in practice, hazard ratios come out of statistical software, and your job is to read and interpret them correctly. Work through all three questions before moving to the solution slide. Through each question. First, the HR of 0.52. Since it's less than 1, the treated group had a lower rate of death. Specifically, at any given time point, treated dogs were dying at 48% the rate of control dogs, or equivalently, the treatment reduced the death rate by 48%. Second, statistical significance. The 95% confidence interval runs from 0.3 to 0.91. It does not include 1, so the result is statistically significant. We can reject the null hypothesis. Third, the clinical meaning. Median survival was 14 months in the treated group versus 9 months in the control group, a 5-month extension. That's a clinically meaningful difference for a dog with lymphoma, and it's consistent with the HR showing a sustained survival benefit throughout the study period. If you'd like more short, clear epidemiology lessons, feel free to subscribe so you don't miss new videos. And if these explanations help make the concepts click, a quick like on the videos tells YouTube to share them with other students who might need them. Thanks for joining, and see you next time.